Hey guys, welcome to my YouTube channel Nujum Al-Samma. Today is our lecture number 6. Which is Chapter 3, Extending Lunar Missions and Preparing for Mars. Let's start. After Artemis 3, NASA and its partners will embark on missions on and around the Moon that also will help prepare us for the types of mission durations and operations that we will experience on human missions to Mars. In this drive toward a more robust human lunar enterprise, NASA, U.S. industry, and our global partners will establish the infrastructure, systems, and robotic missions that can enable a sustained lunar surface presence. To do this, we will expand the Gateway's capabilities, gain high confidence in commercial lunar landers departing from the Gateway, and establish the Artemis base camp at the south pole of the Moon. With the core Artemis elements in operation, SLS, Orion, HLS, the Gateway, and potentially the LTV, NASA is engaging international and commercial partners to pursue additional surface capabilities. With this approach, NASA will leverage years of investment in the systems needed to return to the Moon, while fostering new partnerships and spurring new capabilities to ensure that humanity's return to the Moon is sustainable and extensible to the first human mission to Mars. One such example is an extensible and scalable lunar communications and navigation architecture, known as LunaNet. With a LunaNet architecture in place, robotic landers, rovers, and astronauts on the Moon will have network access similar to networks on Earth. Rovers analyzing samples can send their data to relays orbiting the Moon, which can then transmit that data back to Earth. Astronauts on the lunar surface will be able to receive real-time alerts generated from space weather instruments of incoming solar flares, giving them ample time to seek cover. Each communications link will be a connection to the larger network, allowing data transfers between any assets on the network. LunaNet will also support positioning, navigation and timing, PNT, services and allow for more precise surface operations and science than ever before. This flexible solution to enable exploration and science activities can be provided by a combination of NASA, commercial partners, international partners, and others. This flexibility will be critical as NASA moves forward with its plans for both lunar and solar system exploration, allowing LunaNet to grow in a manner analogous to the development of the Internet on Earth. Numerous potential international partners have expressed their interest in lunar surface operations. International partners could provide key contributions such as rovers, surface habitats, and ISRU-related equipment. Moreover, activities conducted on the surface of the Moon and in cislunar space generally represent an excellent opportunity for NASA to expand its global partnerships, with a focus on new, emerging space agencies. On the surface, Artemis Base Camp. Artemis Base Camp will be our first foothold on the lunar frontier. The three proposed primary mission elements of Artemis Base Camp are the Lunar Terrain Vehicle, unpressurized rover, to transport suited astronauts around the site, the Habitable Mobility Platform, pressurized rover, that can enable long-duration trips away from Artemis Base Camp, and the Foundation Surface Habitat that will accommodate 4 crew on the lunar surface and anchoring Artemis Base Camp and the U.S. presence at the South Pole. Together, along with supporting infrastructure such as communications, power, radiation shielding, and waste disposal and storage planning, these elements comprise a sustained capability on the Moon that can be revisited and built upon over the coming decades, while also testing systems that will be required for human missions farther into the solar system. The additional infrastructure at the base camp will support 1 to 2 month expeditions on the surface to learn more about the Moon and the universe at large, and to develop new technologies that will advance our national industries while developing new resources that will help grow a new lunar economy. The Artemis Base Camp will demonstrate America's continued leadership in space and prepare us to undertake humanity's first mission to Mars. Mobility is vital to the long-term exploration and development of the Moon. In addition to its size, the Moon's geography is complex and its resources dispersed. Evaluating potential sites for Artemis Base Camp, such as near Shackleton Crater, reflects the immense scale of the lunar geography. Robust mobility systems will be needed to explore and develop the Moon and to explore Mars. The habitable mobility platform is a particularly important mission element as the first mission to Mars will use a similar type of spacecraft. See Appendix 6, NASA's plan for sustained lunar exploration development for more on the Artemis base camp and other elements of sustainable lunar exploration. Lunar resources. As our sustained presence grows at the Moon, opportunities to harvest lunar resources could lead to safer, more efficient operations with less dependence on supplies delivered from Earth. NASA has several current ISRU investments through partnerships with industry and academia. Prospecting, extraction and mining initiatives are advancing our capabilities to find and harness resources from the lunar regolith. Chemical and thermal process developments may provide options to break down naturally occurring minerals and compounds found on the Moon and convert them to human consumables or even propellant. Other potential longer-term applications could lead to extraterrestrial metal processing and construction of habitats or other lunar surface structures using resources found on the Moon. Many of these technologies could be demonstrated and advanced on the Moon for future use at Mars. And while the Moon has no atmosphere, we know that the Mars atmosphere is rich in carbon dioxide, so NASA is also investing in initiatives to focus on atmospheric extraction and conversion of CO2 to other useful elements or compounds. In April 2020, the White House issued an executive order, encouraging international support for the recovery and use of space resources, addressing U.S. policy regarding the recovery and use of resources from the Moon and other celestial bodies. This executive order directs the Secretary of State to lead a U.S. government effort to develop joint statements, bilateral agreements, and multilateral instruments with like-minded foreign states to enable safe and sustainable operations for the commercial recovery and use of space resources. NASA is supporting State Department efforts to advance the executive order by conducting a trailblazing purchase of an extraterrestrial resource. Specifically, NASA plans to purchase from one or more providers a sample of an extracted lunar resource for a nominal dollar value. The sample will be delivered in place on the lunar surface for retrieval by NASA at a later date. This process will establish a critical precedent that lunar resources can be extracted and purchased from the private sector in compliance with Article 2 and other provisions of the Outer Space Treaty. In orbit, the Gateway. The Gateway will forge U.S. leadership and establish a presence in the region between the Moon and Earth with our international partners. The orbiting outpost also will offer a unique platform from which to conduct science investigations, with the potential to navigate to different orbits around the Moon. While the Gateway is a much smaller and more focused platform than the International Space Station, NASA is taking the lessons learned from that experience to implement a lunar architecture in which multiple providers of crew systems, propulsion, logistics, science platforms, technology demonstrators, etc., can provide complementary capabilities that increase the overall success and resiliency of the lunar architecture. Early work to define a series of international deep space interoperability standards has formed the basis through which industry and international partners can plug and play into the deep space exploration architecture. NASA and the international community collaborated to define the standards with the goal of defining interfaces and environments to facilitate cooperative deep space exploration endeavors. These standards focus on topics prioritized in this early phase of exploration planning and are not intended to dictate design features beyond the interfaces. The standards include avionics, communication, environmental control, and life support systems, power, rendezvous, robotics, thermal control, and software. Our current space station partners will provide important contributions to Gateway, comprising advanced external robotics, additional habitation, and possibly other enhancements. Canada announced in February 2019 that it intends to participate in the Gateway and contribute advanced external robotics. In October 2019, Japan announced plans to join the United States on the Gateway with contributions of habitation components and logistics resupply. In November 2019, ESA received authorization and funding to support its planned contributions to the Gateway, including habitation and refueling. Russia has also expressed interest in cooperating on the Gateway. The Gateway also will play a pivotal role in Mars mission simulations at the Moon. For these simulations, we currently envision a 4-person crew traveling to the Gateway and living aboard the outpost for a multi-month stay to simulate the outbound trip to Mars, followed by 2 crew traveling down to Artemis Base Camp and exploring the lunar surface with the habitable mobility platform, while the 2 remaining crew members stay aboard the Gateway. The 4 crew are then reunited at the Gateway for another multi-month stay, simulating the return trip to Earth, before landing back home. These missions will be by far the longest human deep space missions in history. They will be the operational tests of our technical and operational readiness for the first human Mars mission.